Hey everybody, Mr. Elliott here. I have something really awesome to show you today. It is called linear programming. We're gonna, we do some story problems in this class, but these are probably the biggest story problems we're going to do all year. Multi-step, so many different parts to it. Um, but if you break it down into piece by piece, not too bad. So I gave you a couple of examples to read before starting this lesson. I gave you this little worksheet here with these two problems on it. If you have not yet read these problems, you should pause this video and read these problems, or at least the first one. So take a minute, read it to yourself, and I will also read it. Let's see, it's about glue all and quick stick. All right. So now that you've read the problem, there's some vocab that I need you to be aware of in these problems, and one of them is constraints. These are basically inequalities that we're going to write along the way to help form our graph, and then our optimization equation where we're going to get our answer from. I strongly recommend in these problems starting with the optimization equation. It's something that we use towards the end of the problem. It's actually usually in the end of the problem. We're not going to use it until the end, but it helps set the problem up if I know right away what my optimization equation is. Optimization equation has to deal with minimizing or maximizing something. So as you read through this problem, first thing to think about is what is it that we're trying to minimize or maximize? And in this case, we are trying to maximize profit. So because we're trying to maximize profit, our optimization equation is going to have to do with profit. So look through the equation or through the problem and find where is it that they're talking about profit. And what we learn is this, is that $1,000 profit per ton of quick stick and $1,500 profit per ton of glue all. So that means that the two parts to this particular problem are quick stick and glue all. And it has to do with tons of quick stick and tons of glue all. So that is going to be our X and our Y in this particular problem. Problem number one. So X and Y, it doesn't matter which one's which, but I usually, oh, it tells us up here, X tons of quick stick. So X is tons of quick stick, and Y is tons of glue all. If they don't specify to you X must be this and Y must be that, it could be either way. You could have this be X, that be Y. You could have this be X, you could have that be Y. You're going to get the same answer, except instead of getting the answer like 10-20, you're going to get the answer 20-10. You just need to be aware that that's what the difference is. And then our optimization equation in this particular case, and we're trying to maximize, so I'm going to write it like this. The max, $1,000 per profit, 100,000, start over, Elliot. $1,000 profit per ton of quick stick. So that is 1,000 X. And $1,500 profit per ton of glue all, so 1,500 Y. And it'd be the amount of profit of quick stick plus the amount of profit of glue all. So this is our optimization equation. Now that we have our optimization equation, we need to come up with some constraints, some inequalities to graph that will allow us to find some solution points. Now, it's a story problem. So we already know that X needs to be greater than 0 and Y needs to be greater than 0. Sometimes they give you like a maximum too. Maximum or minimum. Oh, in this case, it's actually right here. It says there needs to be at least 6 tons of quick stick. That means quick stick is X. X must be greater than or equal to 6. and at least 5 tons of glue all. So y must be greater than or equal to 5. Okay, now, this sentence here, this sentence seems to be all about waste. Next sentence, City Council forbids the company to produce more than 300 pounds of waste each day. Okay, so maybe this glue all is like toxic, so there's a maximum they can have. Okay, so each ton of quick stick, and that's a value of X, produces 10 pounds of waste. So 10 pounds of waste per ton of quick stick. 20 pounds of waste per ton of glue all. So plus 20Y. And it must produce, forbids the company from producing more than 300 pounds of waste each day. So the 10x plus the 20y must be less than or equal to 300. And then also down here it says the total daily capacity of the plant, like how much can they produce, is 20 tons. So x plus y on a daily is going to be less than or equal to 20 tons. Okay, and then these are our 4 constraints based off the problem. So, if you have questions about where these equations come from, make a note as to what your question is, or if you're watching the video in class, pause the video and ask. Next, we're going to get into the graphing. But before I can graph, I actually should solve both of these equations for y, so that so that I'm ready to do some nice graphing. Here, this one, if I subtract 10x from both sides, I get 10y is less than or equal to negative 10x plus 300. Divide everything by 20, and y ends up being less than or equal to negative 1 over 2x plus 15. Second equation, if I just subtract x from both sides, I get y is less than or equal to negative x plus 20. It's good to be able to look at your equations before you get into graphing to make sure that you have enough graph paper for your room. So I want to make sure that I have a y-axis that goes all the way up to 20. And I need my trusty straight edge right here. So let's see, I'm going to make myself an x-axis, a y-axis. I'll start off with a y-axis, then an x-axis. Like I told you yesterday, you want these graphs to be big. The bigger you make them, the better. These are story problems involving graphs. Presentation counts, so you need to label your axes. X was tons of quick stick. So tons of quick stick. Y is tons of glue all. So tons of glue all. Okay, and now let's start graphing these equations. So let's see. I'm going to graph these two first, and then I'll graph my horizontal and vertical lines. So I have negative x plus 20. So let's see. Labeling my graph paper. 1, 2, 3, 4, not 5. 1, 2, 3, 4, 10. 1, 2, 3, 4, 15. 1, 2, 3, 4, 20. So up to 20, and it was negative x, so down 1 over 1. And it could be equal to it. So connect all these dots. And I may have mentioned this before, but the more dots you make it, the more accurate, but then also you're more likely to actually nail an intersection point exactly. Because teachers normally set these problems up to intersect somewhere happy. If you do all these dots, you're much more likely to figure out a good intersection point. This other equation, negative 1/2 x plus 15. So I go up to 15, down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. Ah, there's my intersection point. Down 1 over 2, down 1 over 2. Now I can connect the dots. Connect these dots. Connect those dots. X is greater than or equal to 6. So if I go 1, 2, 3, 4, 5, 6, I've made a critical mistake here. I have not been keeping track of shading. I'm going to have to go back and do that right now. I had x was less than negative x plus 20, and x was less than negative 1/2 x plus 15. So it's actually shading underneath both of these lines. And it's x is greater than or equal to 6, so it's going to be shading to the right of this graph. And then y is greater than or equal to 5. So I go to 5, I draw a horizontal line, and it's greater than it. And if I look at my shaded region, below both of these diagonal lines, but then to the right of the vertical, above this horizontal, this is my solution area. Because this is our solution area, this is the area that works for all 4 inequalities, which means that our answer for the point that's going to get us the maximum profit is one of these 4 points. So this is where you need to figure out where your coordinates are. 1, 2, 3, 4, 5, 6. So this coordinate here is 6, 6, 12. This point here is, so it's a 6, so 7, 8, so start over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like it's at 10, 10, 10. And then this third point over here is 11, 12, 13, 14, 15, 15, 5. Okay, so that is the solution area. These are my points. The answer could possibly be here at 6, 5, but if you're trying to do a maximum, you're not going to get a maximum from this bottom point. It's going to be one of these 3. If the maximum equation is dominating in the x, maybe 15, 5 would be the answer. If the maximizing equation is dominating in the y, 6, 12 will probably be the answer. Whereas if the maximizing equation is kind of balanced between x and y, 10, 10 will probably be the answer. That's just inside information. Anyway, next thing we do is we take, our last step is we need to figure out which one of these 3 points gives us the maximum profit. So the max is equal to 1000x plus 1500y, and then we start plugging the points into them. So I plug in the point 6, 12. I plug in the point 10, 10. And I plug in the point 15, 5. 6, 12. So I have 1000 times 6 plus 1500 times 12. Here 1000 times 10 plus 1500 times 10. Finally, 1000 times 15 plus 1500 times 5. And then see which one gives us maximum profit. I am going to use a calculator here. No, I don't need a calculator. 1000 times 6 is 6000 plus 15 times 12 plus a couple of zeros. So that would be 12 times 12 is 144. So if you added 36, that would be 180. So 180 plus 2 zeros. So we're looking at 24,000. 1000 times 10, 10,000. 1,500 times 10, 15,000. $25,000 profit. 1010 is our winner so far. Next one, 1,000 times 15 is 15,000. Plus 15 times, or 1,500 times 5 is 7,500. That'd be a profit of 22,500. So no matter which one of those 3 points you end up picking, you're actually going to do pretty well on profit, but companies are all about maximizing profit. So this profit is going to be the 25,000. And make sure we answer the question on the end, how much quick stick and glue all should we use? So based off our work with the 10 and the 10, our final answer is 10 tons of quick stick and 10 tons of glue all. Okay, and that is our first optimization problem. The second, all of these problems kind of work the same. So if you want to do one more sample problem with me, we could do number 2 together. But you're already 16 minutes into this lesson, so if you feel pretty good with the one example you saw, you probably do not need to see example 2. And you could just move on with your life. There's nothing new in number 2 that you're going to need to see. Just technique. So pause it if you need it, if you do not want to pay attention, or stop it if you do not want to pay attention, and have a great day. But if you do want to do example 2 with me, check out example 2. Read it for a minute, and then let's work it together. This one is also all about maximizing profit. So the first thing I'm going to do is I'm going to write my maximum equation. Looking on this, profit, this time we're profiting off of painting. Painting is 200, and a lithograph print, 150. So because they mentioned painting first and lithograph second, I'm going to have X be the number of paintings, which means Y is going to be the number of lithographs. And we're trying to maximize our profit. And you're profiting 200 for a painting and 150 for a lithograph. So that would be 200x plus 150y. Next, constraints, inequalities. I first try to figure out if there's a maximum or a minimum for X or Y. Mentions here that they're always going to purchase at least 6 paintings. So you know that X is going to need to be greater than or equal to 6, greater than at least 6 paintings. And then on this case, never more than 25. Oh wait, that's. Sorry, I got ahead of myself. I thought this had something to do with the same thing. The gallery has a policy of purchasing at least 6 paintings, so X is greater than or equal to 6. I noticed they're not saying anything about minimum or maximum number of lithographs. So for that one, I'm just going to make note that Y needs to be greater than or equal to 0. Now the rest of that sentence, it does say, never more than 25 paintings and prints in all at a single purchase. So if you add up the number of paintings and the number of prints, that number must be less than 25. So X plus Y must be less than, can it be equal to? Never more than, yep, less than or equal to 25. Now, the purchase price of a painting is 300. The purchase price of a lithograph is 150. On a single purchase, Cypress will spend up to $6,000 buying paintings and lithographs. So if they're spending $300 on paintings plus $150 on lithographs, they're telling us the total must be less than or equal to $6,000. Okay, sounds good. I have these equations. Next step is I need to solve both of these equations for y. This one, I just need this first equation. I just need to subtract x from both sides, and I'd get y is less than or equal to negative x plus 25. On this one, I subtract 300x from both sides, and then I divide by 150, and I'd get, let's see, negative 300 divided by 150 is negative 2x, and 6,000 divided by 150, 40? Is that right? Because 150 times 40 is 60 with 2 more zeros. Yeah, it is. Yikes, I'm going to need a lot of graph paper for this one. No big deal. I have a lot of graph paper. Okay, so build the problem. Plus 40. I need to make sure my graph paper even has 40 squares to start with. I'm pretty sure it does. Starting here at the bottom, way at the bottom. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 15, 1, 2, 3, 4, 20. Yeah, I'll be able to make it. So as long as I start here, way at the bottom, x-axis, y-axis. In this particular problem, y is number of lithographs. X is number of paintings. And I like marking my graph paper by fives. So 5, 10, 15, 20, 1, 2, 3, 4, 25, 1, 2, 3, 4, 30, 1, 2, 3, 4, 35, 1, 2, 3, 4, 40. And then the other way, on the x-axis, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 25. Okay. Alright, so this first graph, y is less than or equal to negative 2x plus 40. So I go up to my positive 40 point. I go down 2 over 1. Down 2 over 1. I love accuracy on these graphs, so I do a ton of points. At the very least, do 3 points. But if you're exact like me, you're going to want a lot more than 3. That should probably do it. Negative x plus 25, 1, 2, 3, 4, 25. And then down 1 over 1. And I should get an intersecting of these two lines somewhere happy the way that these problems are usually built. There it is. I just heard a bell ring, everybody, so it's probably going to get loud in the next couple minutes as students come filing in. But I really would like to finish this problem. All right, connect the dots. Connect the dots. And both of these graphs were less than. These story problems frequently have less than graphs. So it's going to be below both of these graphs. So far, this would be my shaded area here. So let's see. X needs to be greater than or equal to 6. So I have this vertical line at 6. And I'd shade greater than that. And then y is greater than 0, so the y-axis or the x-axis is going to be shaded above that. So below both of these lines, yet to the right of this vertical and above the x-axis, this is my solution area here. So you shade in the solution area super good, and then you take note of what your intersection points are. In this case, I have one intersection point at 6, 5, 10, 15, 6, 19. I have this intersection point at 5, 10, 15, 10. And I have this third solution point, 5, 10, 15, at 20, comma, 0. So these are one of the three solutions. So I'm going to plug these three solutions into my profit equation. So I'm going to do that down here. So I had the point 619, I had the point 1510, and I had the point 20, 0. So the point 619 with this profit equation, I have 200 times 6 plus 150 times 19. My second equation, 200 times 15 plus 150 times 10. The last one, 200 times 20 plus 150 times 0. And then work these three out. I'm going to do these in my, what I can do in my head. First, let's see, this is a 4 with 3 zeros, so 4,000 plus 0, that's 4,000. Here, let's see, 200 times 15, that's 30 with 2 zeros, so 3,000 plus 1,500, that's 4,500. Pretty promising. 200 times 6, that's 1,200. Everybody! I'm making a video right now. Can you quiet down, please? Thanks. And then let's see, 150 times 19 is 2,850. And if I add that to 1,200, I get 4,050. So, so it's not that one, it's not that one, it's this point 1510, which maximized my profit. So my final answer in this particular case, 15 was number of paintings. So we can get 15 paintings and then 10 lithographs. Alright everybody, and that's these story problems. Even the second one that I was trying to work a little bit faster as your teacher who knew what was happening, it took me 10 minutes. So these problems are going to take a long time to do problem by problem. The first couple, it might take you like 20 minutes, half an hour. But you want to keep slimming that down, so you want to hope to be able to solve these problems out in roughly 10 to 15 minutes. Anyway, I got to teach fourth period now, so I'll talk to you later. Have a great day. Hey, fourth period.